Today's lesson is about review for arithmetic and a geometric sequence in a series. 1a. The first three terms of an arithmetic sequence are usable 1, 5 usable 1 minus 8, and 3 usable 1 plus 8. Show that usable 1 equals 4. Since this is an arithmetic sequence, we do know the D common difference equals u sub n minus u sub n minus 1. Therefore, this is u sub 1, u sub 2, u sub 3. We can set up u sub 2 minus u sub 1 equals u sub 3 minus u sub 2. So u sub 2, that's 5 u sub 1 minus 8. Minus u sub 1 equals 3 u sub 1 plus 8 minus parentheses 5 u sub 1 minus 8. Then combine like terms 4 u sub 1 minus 8 equals distributive property 3 u sub 1 plus 8 minus 5 u sub 1 plus 8. Combine like terms, negative 2 u sub 1 plus 16. On the left side, we have 4 u sub 1 minus 8. Since this is a linear equation, isolate the variable on one side. So we have 4 u sub 1 plus 2 u sub 1 equals 16 plus 8. 6 u sub 1 equals 24, divided by 6 u sub 1 equals 4. For 1b, prove that the sum of the first n terms of this arithmetic sequence is a square number. We know s sub n equals n over 2, 2 u sub 1 plus n minus 1 times d. We already know u sub 1 equals 4. Then we plug in here 5 times 4 minus 8. 3 times 4 plus 8. 4, 12, 20. So we know the common difference equals 12 minus 4 equals 8. U sub 1 equals 4. So we plug in here n over 2 times 2 times 4 plus n minus 1 times 8. Distributive property equals n over 2. 8 plus 8n minus 8. Combine like terms, n over 2 times 8n. Cancel. So we have 4n squared. I can write down 2n squared. So s sub n is a square number. Let's go to 2a. Consider the function f of x equals a to the x power, where a and x are real numbers. X is greater than 0 and a greater than 1. The graph of f contains the point 2 over 3, 4. Show that a equals 8. Whenever you see the point is on the graph or the graph passing through a point, you just need to plug in. This is x, here is y. F of x is y. So we will get 4 equals a to the 2 over 3rd power. How to get this a? If I have a to the n over m's power equals c, we will do power of a power m over n, m over n. So we have a equals c to the m over n's power. Then you can get nth root of c to the m's power. So both sides, we will do 3 over second power. 4 to the 3 over second power. For this 4, I can write down 2 squared times 3 over second power equals, reduce. You will get a. Then 2 to the third power equals a. A equals 8. To b, write down an expression for inverse of f of x. We already know the function f of x equals 8 to the x power. Then the inverse function will be inverse of f of x equals log base 8 of x. For 2c, find the value of inverse of f of square root of 32. So inverse function, inverse of f of square root of 32 equals log base 8 square root of 32. We will use log base a to the nth power of a to the m's power equals m over n to figure out this value. We will get log 8 will be 2 to the third power. Square root 32, we can write down square root 2 to the fifth power. So we will get 2 to the 5 over second power. That is 2 to the 5 over second power. So we get 5 over 2 over 3. Drop down because this is a complex fraction. 5 over 6. For 2D, consider the arithmetic sequence. Log base 8 of 27, log base 8 of p, log base 8 of q, log base 8 of 125, where p greater than 1 and q greater than 1. Show that 27, p, q, and 125 are 4 consecutive terms in a geometric sequence. If 27, p, q, and 125 are 4 consecutive terms in a geometric sequence, we need to show that common ratio R equals p over 27 equals q over p equals 125 over q. From the given information, we know log base 8 of 27, log base 8 of p, and log base 8 of q. Log base 8 of 125 are arithmetic sequence, which means the common difference equals log base 8 of p minus log base 8 of 27 equals log base 8 of q minus log base 8 of p equals log base 8 of 125 minus log base 8 of q. Then we can condense the log here. We will get log base 8 of p over 27 equals, condense this one, log base 8 of q over p equals log base 8 of 125 over q. From this equation, since the bases are the same. So we have P over 27 equals Q over P equals 125 over Q. So 27 P Q and 125 are four consecutive terms in a geometric sequence. Let's go to 2E. Find the value of P and the value of Q. We already know P over 27 equals Q over P equals 125 over Q. From this equation, cross multiply, we know P squared equals 27Q. From these two, we can get P over 27 equals 125 over Q. Cross multiply, I want to solve this Q equals 125 times 27 over P. Then I plug Q equals 125 times 27 over P into this equation. We will get P squared equals 27 times 125 times 27 over P. Then we multiply by P both sides. We will get the P to the third power equals 27 times 125 times 27. Then we will do the cubic root both sides. P equals cubic root of 27 is 3. Cubic root of 125 is 5. Cubic root of 27 is 3. So we get P equals 45. Then for the Q equals 125 times 27 over 45. Reduce by 9 first. This is a 5. This is a 3. Then reduce. Here is 1. This is a 25. 25 times 3 will be 75. So Q equals 75 and P equals 45. The reason why I choose these two, not choose Q over P equals 125 over Q, is that I don't want to create a Q squared. Use these two, I can easily to figure out either Q equals or P equals. Then I can do the substitution to figure out the variable.